everybody, and welcome to another episode of the IaC Podcast. I'm your host for today. My name is Ohad Maislish, and today with me, the Docker uh, original dev advocate, Jérôme Petazzoni. Welcome, Jérôme.
Hi, Ohad. Thanks for having me.
For those who still don't know you, Jérôme, please introduce yourself and your super impressive background.
I don't know if I would call it super impressive, but yeah, I was part of the band formerly known as Docker, as we used to say. I worked at Docker ever since 2011, so before it was Docker. And there I had multiple hats. I was an SRE, then I accidentally became Docker's like first evangelist or advocate,
Mhm.
lived out of a suitcase for a few years. And then I left in late 2017, early 2018. And since then, I'm more of a independent freelancer and I do training and consulting on Docker and Kubernetes.
Awesome. Yeah. So we talk about infrastructure as code, and I think we usually talk about things like Terraform, OpenTofu, Pulumi, CloudFormation that provision cloud infrastructure with code. But I think the first representation of resources in code was Docker. So instead of having an image of a virtual machine or something like that, you start having those Docker files that represented what you're going to get and what kind of infrastructure you can use within your container. So, can you tell me more about Docker files and how the first few versions and what was the reaction? What was the aha moment of the first users that started using those Docker files? I think this is fascinating. Like, this is history in making.
So from the inside, of course, we saw people get super excited about Docker, and of course, that made us really happy. And my personal interpretation of that, I'm not saying it's absolute truth. We could debate about this, but my understanding is that we got the benefits of infrastructure as code and declarative mechanisms without the pain that comes with it. Because when I teach Docker, for instance, and I need to teach a Docker file, I tell people, okay, it's really easy. You start with a shell script, and then you put run in front of each line, and then from at the beginning of that file, indicating your base image, and that's it. That's your first Docker file. Okay, it's not going to be the best Docker file and we can iterate and refine and so on, but that's going to be a starting point. And in like 5 minutes, you can have your first Docker file, build your first image, and that works. And when you start making small changes, you get all the magic of the build cache, which I think was a huge part of Docker early success. Because before we always had this kind of dilemma. Am I going to use something like, let's say, Chef or Puppet, and it's very declarative, but there is a huge learning curve, and and maybe you've heard that joke about how if you really look closely to any Chef or Puppet, like manifest and configuration, it's always like three bash scripts in the trench code. You always end up like somewhere deep down there is always a bunch of not so clean shell scripts to do some heavy lifting. Or you decide, well, I'm going to just use shell scripts in the first place to do my server setup and configuration, which is way easier at first because I don't need to learn Chef, Puppet, Ansible, etc. But in the long run, that's way harder because I need to think about all the possible cases. Also, it's not really idempotent, which is a fancy word to say if I run it 5 times or 10 times or 15 times, it's going to behave the same way. And that's pretty important. Like if we have a script, but it only works the first time,
Yep.
then it means each time we want to run it again, we need to start from completely over, like from scratch. And And if your script takes 20 minutes, then yeah, you waste 20 minutes each time. So it feels like Docker gave us a middle ground where it's going to be relatively easy, like a little bit harder than writing a shell script, but not much harder. But we're going to get all the good bits of declarative systems, even though technically, I guess it's not a declarative system. You know, when you said it was infrastructure as code, a part of me is like, is it really? Maybe, I'm not sure, but it gives us the advantages of being able to build and rebuild really quickly and in a deterministic way. I think when I teach all that stuff, like some of the best metaphors that come to mind is like when you play video games.
Mhm.
Like with Docker files, it's like when you can save after each difficult level, after
Yep.
each boss, etc. You can save so that if you lose further down the line, instead of having to restart completely from scratch, you can just load your last save and try again. That's
Yep.
exactly what Docker gives us, basically.
Iterative programming for infrastructure in a way, and also to boot a Docker image takes a second, unlike a virtual machine that can take minutes. So every iteration is very, very quick, and you can check what's going on
Exactly.
very
Yes.
quickly. Interesting that you mentioned Chef. Just a shout out to Adam Jacob, the creator of Chef, that was another guest in one of the previous episodes of this podcast. If the listeners here want to learn more about Chef, I'm pointing them to the episode with Adam Jacob, the amazing Adam Jacob. Okay, so let's move from Docker to Kubernetes. And usually, when I talk about a cluster of nodes that can run Docker containers in scale, we naturally talk about, okay, Kubernetes, it's the obvious way to do that. That's the most popular. But you work for Docker, and not sure if a lot of people know or remember about something called Docker Swarm that was supposed to solve a similar problem, but eventually, as I mentioned, not a lot of people talk or know about Docker Swarm. Everybody just uses Kubernetes, or almost everybody. You work for Docker, you know Docker Swarm, and you also obviously know Kubernetes. Can you tell us a little bit about Docker Swarm versus Kubernetes, and why do you think that Kubernetes is a lot more popular versus Docker Swarm?
Sure. Well, I guess there would be many, many reasons for that.
Mhm.
One of them would be perhaps that there was actually a really tiny team working on Docker Swarm in the early days, and that team started fairly late compared to Kubernetes.
Mhm.
And maybe if we do a kind of root cause analysis, why did that happen? Um, I don't remember the exact dates, but somewhere in maybe late 2013, early 2014, like some of the Kubernetes folks came over to the Docker office and basically were like, hey, we have this orchestrator. We think it would be a great addition to Docker. And if I remember correctly, the sentiment was, yeah, that sounds nice, but that also seems extremely complicated. So thanks, but no thanks. And to be
Wow,
fair,
wow,
it's
that's that. Yeah, it is complicated. To provision a Docker
yeah.
Swarm cluster, it's one line of execution, and we're gonna talk later today about what it means to provision Kubernetes clusters in the main public clouds and other clouds. Definitely, Docker Swarm is much simpler. But please continue. It's super interesting to hear the story behind the scenes.
Yeah, I think the Docker team back then decided, okay, we want something like that, but we want the user experience to be simpler, and we want the learning curve from Docker to orchestration to be also simpler. So that was kind of the idea behind Docker Swarm. Now, the first iteration of Docker Swarm was really a super crude hack. It was like, hey, you have this thing that exposes the Docker API, but when you run containers, when you Docker run, it's going to throw these containers left and right. And it kind of worked a little bit, but It was more like, yeah, a hack, but it showed that it was possible. And then later there was the re-implementation of Swarm that became known as Swarm mode. So now you have this confusion between Swarm Classic and Swarm mode.
Mhm.
Swarm mode came out, I think, in mid 2016, but I think even though, I mean, it was great, and I'm going to explain why just after, but it was too little, too late. Kubernetes had been around for 2 years already. There was a huge momentum behind it, and I think I was kind of guilty of being in that echo chamber where I would, for instance, I would teach Docker Swarm to like 50 people at a conference, a workshop, etc., and they would be like, "Oh, thank you for saving us from Kubernetes because we tried and it's so complicated, but with Swarm everything makes sense, etc., etc." So they were like, "Well, apparently we're doing the right thing because people
Mhm.
say that they like this better." And the thing is that, yeah, that was pretty much the definition of an echo chamber, because we had people who maybe either they didn't want to bite the bullet and tackle that learning curve, or maybe the first exposition they had to Kubernetes was not so great, and so they felt, okay, this is simpler, let's use that. But very often, and I think it's not just in tech, but in the world in general, when there is the easy way and there is the hard way, and often in the long run, the hard way turns out to be better. And sometimes if we want to accomplish great things, we have to go through the hard way and
Yep.
learn to do things. And so I think that was one of our issues. Now, if we go a little bit on the technical side, I think in Kubernetes, things are broken down in many components. And yes, it can appear complex, but you can take each of these components and understand what they do individually.
Yep.
And in Swarm, it's more like this all in one kind of,
Monolith.
yeah. It has some advantages because the footprint is much smaller, it uses less resources, because basically it would be as if in Kubernetes you took the entire control plane and kind of including etcd and smooshed it in a single component. So you save a lot on RPC and things like that. But it also means that extending it is much more complicated. And I think this extension potential is one of the things that made the strength of Kubernetes.
I
Oh, you want, yeah.
Yeah, I fully agree. I fully agree. When things are decoupled and each team, different expertise, different communities, even just try to evolve and make some capability of that technology better, and they don't need to be related or coupled with other existing code or teams. So yeah, I fully agree that this is also very very important. And Kubernetes just celebrated 10 years not too long ago, so it's interesting to hear stories from 10 years ago when Kubernetes started and what happened at Docker back then. Okay, so now that we understand or agreeing with your rationale to what made Kubernetes more successful than Docker Swarm. So we had Docker, then we obviously had Kubernetes that evolved very quickly, as you mentioned. Um, what are your thoughts about the value of Kubernetes? I'm sure we all have our own opinions, but what are your thoughts? And if you can describe the value of Kubernetes to its users, how would you describe it?
Hmm. So for me, and again, caveats and so on, like this, maybe this is not a universal answer, but for me and for I think a lot of ops, SREs, and maybe even devs, the value is that it gives a pretty good abstraction to use cloud resources. And when
Mm.
I say use cloud resources, I'm not talking about, oh, I'm just spinning up one VM and installing a bunch of packages to run like a single service, but more like the step after that, which is, My app needs to run on multiple machines. I need to have some kind of scaling. I need also some kind of failover because in the cloud, sometimes we have outages, even more frequently than on prem. So we need to be ready for that. And uh, of course, I can do that using, if I'm on AWS, I can do auto scaling groups and ELBs and etc. If I'm on other cloud providers, I have equivalent things. But the advantage of Kubernetes is that I can learn how to do these things once with Kubernetes, and then I can go on pretty much any cloud, and it's gonna work in a very similar way. And sure, we can debate of like, but when you move to a different cloud, you still have things to change, and that's true. But as far as Kubernetes is concerned, my favorite anecdote was from a few years ago. Um, I was delivering a Kubernetes workshop for folks at VMware, and we so when I do a Kubernetes workshop or training or whatever, I always give everyone their own Kubernetes cluster. So if we have 100 students, we have 100 clusters. And this time, for some reason, I couldn't just spin up 50 clusters on AWS or whatever. So instead, I ended up having maybe 20 on AWS and 20 on some VMware internal lab and 20 on some OpenStack that I have access to. And so what we do is that we print little cards with the IP addresses and login and passwords, and we give these little cards to everyone at the beginning of the workshop, and people learn to deploy deployments and load balance some load balancers and so on and so on. And at the end, we told them, hey, by the way, look at the little card with the IP address of the cluster. If it starts with, I don't remember exactly, but like 45, it means that you are on a private cloud on OpenStack. If it starts with 64, you are on a VMware lab using, I don't remember if it was Tenzu or PKS or whatever back then. And if it starts with something else, then you are on AWS. Now, during the whole workshop, during the whole day, everyone ran exactly the same commands, used exactly the same YAML manifest. We did everything the same way, and we ended up with the same apps, but sometimes on OpenStack, sometimes on VMware, sometimes on AWS in a public cloud. So as you can see, um, Kubernetes gives us a fairly good abstraction layer so that we don't have to think about what kind of cloud we have behind the scenes. Of course, this is a little bit naive because as soon as you start using, like S3 or other object stores or any kind of IAM integration, etc., then of course you need to know what's the cloud that you use behind the scenes. But this will typically be a concern for what I'm gonna call the platform team, like the folks that sit in between the infrastructure and the dev teams. And so yeah, these folks will need to know about the specifics of the cloud that we use, but they're going to expose a nice and clean abstraction for the, let's say, devs with a really big umbrella for the term devs that are deploying apps on these clusters. And I would argue, and I'm not gonna die on that hill, but I would argue that it's easier to learn Kubernetes than to learn pretty much any other abstraction given to us by cloud providers these days. Like I think AWS is probably one of the worst, just because if you want to do things the right way, there are so many things that you need to layer up. And if you want to do things the right way from a FinOps perspective, now you need to talk about, spot instances and auto scaling and et cetera, et cetera. So I think here Kubernetes is doing a good job of kind of leveling things together.
Yep. I also want to mention also about storage and FinOps. There are different types of storage that you can use in AWS, so you need to be
Absolutely, yeah.
mindful of which kind of resources to use. All right, great. So we talked about Docker and then Kubernetes and its value. Now, Jerome, from our earlier conversation, sounds like you have vast experience in using Kubernetes, not in one, not in two, not even in three different providers, but in maybe every provider that offers Kubernetes. And you've tried to understand how to use it effectively and provision it using the leading IaC framework, which is Terraform. Can you share with the audience what you've been trying to do and what are your learnings on how to provision and then how to use Kubernetes in real life in different providers?
Sure. So, like I mentioned earlier, when I teach a class or workshop, I like to give every student their own cluster, and so that means having ways to deploy clusters in bulk. And so, of course, that means infrastructure as code. Well, of course, in the beginning, not really. In the beginning, it was a lot of really dirty scripts and parallel SSH and all that stuff. And over time, it moved to infrastructure as code. And the thing is that when I teach these classes, sometimes it's going to be for maybe a US company who's going to tell me, oh, we work with AWS, so we would like the clusters to be on AWS. And I could tell them, well, whether the clusters are on AWS or Linode or whatever, it's not going to change anything. But in that case, I'm like, yes, sure, the clusters will be on AWS. Sometimes they tell me, well, no, maybe they are a competitor to AWS and they don't want the clusters to be on AWS. Or sometimes I'm going to teach something in Europe and then I'm going to use a European cloud provider. And so I started, by supporting a small number of providers, for instance, Scaleway, which is a French one, because if I'm teaching a class for French folks, I might as well use a French provider, and also they're pretty good, so why not? In Germany, I would often use Hetzner for similar reasons. In the US, it could be Linode, it could be DigitalOcean, it could be AWS, it could be Azure, GCP, and so little by little, it grew from 3, 4, 5, 7, 10, and now I think almost 12 different cloud providers.
12.
And I,
Wow.
and I think it's just like, when learning languages, programming languages or speaking languages, but also like when learning to play an instrument. The first one is really hard. The second one is still hard, but at least you have some references, and from the third one and on, it gets easier and easier. Like if you already know how to speak Italian or Spanish, French is going to be easier, for instance.
Yep.
So same thing here. After the sixth or seventh provider, it gets like much 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 easier. And I think a good example was just before a presentation in France. I wasn't supporting OVH yet, which is a huge French hosting provider. And I think half an hour before the live stream, I was like, you know what, it would be nice if I added OVH. And it took me like maybe 20 minutes, half of it being waiting for the resources to come up, and it worked. I think
Mhm.
I also was a little bit lucky, but it made me feel really good. So that was, that was an interesting learning experiment. I even drew a talk from that, because I think the story is that at some point I was in Berlin and there was like maybe the DevOps meetup, and they were like, hey, we don't really have any talks for tonight. And so if you have something, so I just sent that thinking, hey, sure.
Yep.
Um, and well, it turns out that they ended up having many propositions, and the first speaker in the meetup was actually a real Terraform expert, not
Uh-huh.
not like me, who I consider myself like an amateur with Terraform. But and so I felt extremely self-conscious when it was my turn to present. I was like, whoa, I learned a few useful things from that guy before, and I think I need to edit my configurations now. But let me present you anyway, like how we're going to deploy Kubernetes clusters on, like, I don't remember if it was 9 or 10 different cloud providers. And what I found really interesting was to compare the size of the Terraform configuration and the time that it takes to provision these clusters. So the time, it's not really related to infrastructure as code, and
Yeah.
many people were like, who cares about how long it takes? And I'm like, well, I care, because if you do end-to-end testing, for instance, if you're working on a Kubernetes operator, you might need to provision a new cluster and install the operator and the CRDs, etc.
In some
And
use
so,
case, yeah. Some use
yeah,
cases,
some
it's very relevant.
totally.
Yeah.
And then it's kind of great if it takes 5 minutes versus 45 minutes. But the other interesting aspect was the size of the configuration. And there was a difference up to a factor of 5 between the smaller ones and the bigger ones.
You're talking about
Um,
the lines of code that you need in Terraform in order to provision
exactly.
a
Yeah,
Kubernetes cluster in the cloud provider. So,
exactly.
so you're saying
Um,
5x. What does it mean? Like how many lines versus how many lines?
So for the smallest ones, it was about 100 lines, and for the biggest one, it was about 500.
And
Um,
and is that using the actual Terraform provider or using some well-known modules that can help you with provisioning the clusters?
Both. So the if I remember correctly, and I have all the code online, by the way, so we can share the URLs and everything if some people are interested.
Please, yeah.
The biggest ones were, I think, Google Cloud and AWS and Oracle, with about 500 lines. And for AWS, I had to use modules too, and I was kind of shocked. Wow, that's a lot of configuration, and a lot of that is, well, you need to create, before you can deploy your cluster, you need to create a VPC, and you need to declare subnets, and you need this and that. And if you want to have persistent volumes, you need to install the some part of the EBS like roles, so that the cloud controller manager has the right permissions to create the volumes. So it's a lot of little details, where on some providers they kind of hide all that complexity, and you
Nice. Yep.
literally
That's
have a
good.
single Kubernetes cluster resource, and that's it. And on some others it gets more and more complicated. Or do you have to declare your node pool separately? How far do you need to go with network configuration? Do you have to manually declare the security groups and rules? All that stuff,
Yep.
basically.
But back to Docker Swarm and Kubernetes, I wonder what is better for the users. Do you want to have full control on the different pieces within your infrastructure? Or do you prefer the simplicity and hiding the small details from you? You just want it to work. So it's those are two valid approaches. In the case of Kubernetes versus Docker Swarm, the more complicated and powerful approach um, won. But here you're talking as an end user that just wants to provision a Kubernetes cluster, make it quick, make it with not too many lines of code that I need to write and maintain in order to have this Kubernetes cluster. Now, besides provisioning those Kubernetes clusters, after those clusters are provisioned, you just obviously want to use and access those Kubernetes clusters. Have you seen any different approaches to that? Meaning, after you provision, what can you do with the outputs, or how you can literally start using the cluster? I think you've told me that you've seen some interesting data points for that as well, right?
Yeah, absolutely. So I think if you really want the simplest thing, you could, because when you want to access a Kubernetes cluster, you need a kubeconfig file. And the simplest thing would be to use a cloud specific way to obtain that. So for instance, if you are on AWS, there is an AWS CLI command, like I don't remember it on the top of my head, but something like AWS EKS get kubeconfig dash dash cluster blah blah blah, and that's going to get the kubeconfig file. But in my case, I was like, no, that's cheating. I want the kubeconfig to be a Terraform output. And
Yep.
because the end goal is that I can basically just like switch my Terraform modules around. I get the same inputs, the same outputs. Like the input should be how many clusters do you want, maybe a notion of a region or zone or whatever the cloud provider calls it, maybe the size of instance, and I think that's pretty much it. And the output should be a bunch of IP addresses and kubeconfig files. And so what I found interesting is that in some cases, obtaining the kubeconfig is really easy because it's going to be like directly um, an attribute of the cluster resource. So making it as an output is super straightforward, like a couple of lines. But sometimes it's like, no, no, no. If you want a kubeconfig file, you will need to completely assemble it by hand. So you're going to retrieve the address of the API server and the certificate used by that and the credentials and so you end up having like 20 or 25 lines of Terraform
That's
uh,
that's
just
that's
to
super. Yeah, that's super interesting because, as you mentioned, the cloud providers usually have one CLI command to help you with that, but it's not necessarily as easy to do, at least nowadays, with code, right? They have different approaches to their CLI and their Terraform providers.
Yeah, and I think that made me realize that when evaluating, which cloud provider am I going to pick, um, I think we should also pay attention to how much work is it going to be to automate and industrialize my
Definitely,
deployment.
definitely.
Um, I should that be the main factor? Probably not. I'm sure
Probably,
we
but
also, but I think that should matter,
I
at least
fully
a little
agree.
bit. Yeah.
I think there are a lot of aspects and considerations to which technology to use, and from my experience, we see with customers eventually choosing more than one because there are some pros and cons. There are some advantages of using one technology, and there are some advantages of using a different technology. So depending on your architecture, depending on your use cases, depending on your FinOps, concerns and let's say constraints, that
Yeah.
leads you to different decisions. And I think what we've learned today from you to also look on the amount of work you need to do in order to do the simple things, the straightforward things, um, and how this affects your overall decision making process, right?
Yeah, and I'm thinking back about something you mentioned earlier about do we want, like we talked about, is it better to go the easy way or the hard way, but having
Mm.
something that is more future proof. And I was thinking the ideal scenario would be, well, give me something that's easy in the beginning, and then little by little, if I need more advanced features and more complexity, I can build on top of that. And kind of echoing what we said in the very beginning when we were talking about Docker files, I think Docker files kind of nailed that in the sense that,
I
as
fully
we
agree.
said earlier, in 5 minutes you can get a quick and dirty Docker file. And then you can build on top of that, like, okay, let's add better caching. Let's learn about like fancy build kit features and
Yep.
multi-stage and blah blah blah.
Yep.
So
It's
yeah, I think that worked pretty well. Um, and for the now, if we go back to infra as code and Terraform configs, I think here there is a big it depends. Sometimes when I need to make changes to a configuration, I can see, oh, there is a whole world that is now available to me. And sometimes it's like, well, you need to delete everything and kind of restart from scratch and use something completely different. Um, Plus there is the added complexity of it's not just about refactoring my Terraform configuration, because I would say this is almost like the easy part. But what if I have existing infrastructure? How do I make sure that when I'm going to Terraform apply, it's not going to delete and recreate my cluster? And I mean, we are we're extremely lucky that, with Terraform Plan, at least you can know what's going to happen. And there is a pretty incredible ecosystem around Terraform giving us so many insights. I'm like, to be clear, I'm not an expert in that, but regularly I see, oh, look, we have this thing that's going to show you the difference in cost, in infrastructure
Yep.
after you apply that
Yep.
plan. Or I was talking to another company who's working on something to, identify, oh, when you have an outage, where does that correspond to in your Terraform configuration, etc. So we have many things there, but still, if I, if I'm like, I'm refactoring my Kubernetes Terraform configuration because now instead of having an embedded node pool, I want to have a separate node pool. How do I do that without destroying all these nodes in the process, for instance? And yeah, um, that's the kind of challenge where when I'm facing that, I know it's going to be hard, and I know that I will want to have an expert with me to help me figuring it out, because yeah, these
Definitely.
things are hard.
Awesome. Thank you, Jerome, for walking us through the journey of Docker Swarm Kubernetes, and then Terraform, and how to use Kubernetes at scale or at speed or with simplicity, with different options. And there are so many options out there today. So thank you for sharing, you know, your journey and your thoughts and your vision about the space. So thank you, Jerome, for joining today, and thank you everybody today for listening to another episode of the IaC Podcast. And I hope to see you here next time in the next episode. Bye bye, Jerome.
Bye. Thanks.